Internet protocol, how it is used as an address, like your name. Some of your name is Robert Robert Jessoff. So basically, it says that you have certain first names and the last names. So usually the names are the comments of an individual's, and also the address recommends of an individual's, which basically signifies where the person is located. Same thing in case of IP address, we try to put some address into it to find out from where this IP address is generated and from which address to which address it is making handshakes. So in order to do that, each IP customers has to have their own address. Whenever you apply for internet, you are given with a specific address and all the specifications of the address, and you usually use that for the sake of using internet. Now, today in our class of chapter 6, we will be discussing IP addressing, what is IP addressing, and what is the objective of it. So IP address, initially we will start with IPv4 addressing. Use classless interdomain routing notations, perform subnetting calculations, configure IPv address, describe network address translations, describe IPv4 address types, auto configurations, and transactions methods. So we will define two different kinds of address here, IPv4 and IPv6 in these chapters. And also we will discuss about how from one domain to other domain, this interdomain routing notations happens, how the handshaking happens between the one router to the other routers or one IP address to the other IP address, and how do you perform the subnetting calculations, means from one net to other nets, that is the subnets. How do you do that? How do you configure an IPv4 address? And how do we network address translations? Describe basically how we translate an address. And then second one is IPv6. What is this address types and configurations, and what is the transitioning methods between IPv4 and IPv6. So these are the few things, very crucial aspects of the Internet protocol family we will discuss today. Now IPv4 addressing. Address is a 32-bit number divided into 4 bits. Four 8-bit values called octets. Each octet can have a value of from 0 to 255. So IPv4 address has a 32-bit number. Any IP address has a 32 bits number, and that is divided into 4 of 8 bits characters, which is called, each 8-bit characters are called octets. Each octets can be valued from 0 to 255. 4 decimal numbers are separated by periods in a format called dotted decimal notations. So each 1 is, there's a like 0000, then dot, then each four periods followed by a periods, and in a format called dotted decimal notations. Subnet masks are also 32-bit numbers that serve to determine how many bits are allocated to a network ID and how many are allocated to host ID. So basically, what happens is when you have an IP address, you have in the IP address, you have 32-bit number which is divided into 4. Each one is called octets, and they are basically divided by pause, by periods, and called dotted decimal notations. After 4 decimal numbers, you are separated by periods are called dotted decimal notations. The subnet mask also have a 32-bit numbers, and they serve to determine how many bits are allocated to a network ID. So from network ID, there's a subnet. If you want to, there's a host and then the subnet. From the host, you have a 32 bits, and again in the subnet, you have a 32 bits. When written in binaries, 1S is the subnet mask that corresponds to bits in the IP address. So in the subnet, usually we use 1 to correspond to the specific IP address. Mean the matching bit locations are marked on the of the network ID. See the how it is happening. Example. So the first one is IP address, and then it's followed by bits with 0, 1 is a binary numbers. How is the subnet mask used to determine the network ID? Computer determines the network ID by doing a logical and operational between its IP address and the subnet mask. Usually, you have a network ID, but it's how do is the subnet mask used to determine the network ID. To determine the network ID, you have to use subnet mask by which you can determine which one is your network ID. Computer determines the network ID by doing logical and operations between its IP address and the subnet mask. Logical and its operations between two binary values and operations can have the following results: 0 and 0, 1 and 0, 1, 0 and 1, and 1 and 1. So these are the 4 different ways you can have the operations. Finding the subnet mask, the logical and operation between the computer IP address and the subnet mask looks like this. Zero 1 0 0 0. So basically the subnet mask has the logical and operational aspects between a computer IP address and the subnet mask. It looks like a 2 binary numbers. Converting binary to decimal. Review how the decimal number systems works. 0 through 9 are used to represent any possible number. 0 through 9 represent any possible number. Each place in the decimal number can 10 possible values. The one place can be expressed as a number 0 through 9 multiplied by 10 raised to the power 0 power 10 to the power 0. So basically converting binary to decimal is how do you do conversions from binary to decimal? 0 through 9 are used to represent any possible number. In a binary case, usually we represent 0 to 9 for any possible number. Each place in a decimal number can 10 possible values. The one place can be expressed as a number 0 through 9 multiplied by 10 raised to the 0 power or 10 to the power 0. The decimal number 249 can be expressed as either of the following. See how it is expressed. 2 into 10 to the power 2 means 10 to the power 2 means what? 10 into 10 is equal to 100. So 100 into 2 gives you so the decimal number 249 can be expressed as follows. How it is? 249. So 2 into 10 to the power 2. 10 to the power 2 means 100. 10 into 2, 10 is equal to 100. So usually 10 to the power 2 means 10 to the power 10 into 10. If it is 10 to the power 3 means 10 into 10 into 10. 10 to the power 4 means 10 into 10 into 10 into 10. The 4 times you have to multiply 4, multiply 10. That means 1,000. If it is a 10 to the 2 means it's a 10 square. 10 square means 100. So it is 200 plus 4 into 10 is equal to 40 plus 9 into 10 to the power 0. That means what? 10 to the power 0 means 1. 10 to the power 0 means 1. So 9 into 1 is equal to 9. So what is it? 2 into 10 to the square is equal to 200 plus 4 into 10, 40, 9 into 10 to the power. So basically what we did is we tried to represent the whole binary number with the 10. So 2 into 10 to the power 2 is equal to 200, 4 into 10 to the power 1 is equal to 40, 9 into 10 to the power 0 is equal to 9. So the total is 249. So we represent 249 with 10 and it says 249. So whenever we convert binary to decimal, it has to be used 10. Suppose now if I give you 379, 379, if it is 379, how do you do that? 3 into 10 to the power 3 or 3 into 2. So is equal to 300. 3 into 10 to the power 2 is equal to 300. Now you have to go 79. So how do you do that? 7 into 10 to the power 1, which is 70. And then 9 into 10 to the power 0, which is equal to 9. So 3 into 10 to the power 2 is equal to 300. 10 into 7 is equal to 70. 9 into 10 to the power 0 is equal to 9. So total is 300 plus 70 plus 9, 379. So conversions of your digital binary to decimal, we have to do this way. Okay, now I must tell you one thing, my students, that this chapter you have to understand, and there is not much explaining much, but you have to go into it, read line by line, and whatever I'm trying to explain, if you can listen to it, I hope you will understand. But it is little difficult for the people who has no conception about the mathematics. It will be little difficult for them. If you have any difficulties, let me know. Because it's a math, it's a binary conversions, binary math, converting binary to decimal. When binary arithmetic, there are only two possible values. In any binary arithmetic, we have to understand it is present with 1 and 0. 1 and 0. For example, using the same method you used to solve the decimal example, you can express binary number 101 as either of the following, numbered in bold or binary digits. Like if you want to represent 101, how do you do that? 1 into 2 to the power 2, which means 2 to the power 2 means 2 into 2, which is equal to 4. 1 into 4 is equal to 4. Plus 0 into 2 to the power 1. What is it? 0 into 2 to the power 1 is equal to 0. And 1 into 2 to the power 0 is equal to 1. So it comes 4 plus 0 plus 1, which is equal to 5. See how this binary number 101 has been converted to decimal. Very interesting. How this binary number of 101, which has to comprise of 011, now we are trying to convert it into the numbers in bold are binary, 1, 0 are all binary. So you have to convert 101 into a decimal number. How we are doing that? So 1 into 2 to the power 2 is equal to 4. 0 into 2, we have to use 1 and 0, I said. So 0 into 2 to the power 1 is equal to 0. Anything multiplied by 0 is equal to 0. And 1 into 2 to the power 0, 2 to the power 0 means anything to the power is equal to 1. You have to remember, if it is 100 to the power 0 is equal to 1. 10,000 to the power 0 is equal to 1. Whatever the number is, but if its power is 0, then it is 1. So 1 into 2 to the power 0, 2 is equal to 4. 0 into 2 to the power 1 is equal to 0. Because anything multiplied by 0 is equal to 0. 1 into 2 to the power 0, again 2 to the power 0 is equal to 1. So the total comes 5. Now, see this. We are converting a binary number to decimal number, and that is 101, which is equals to 5 in decimal. In the binary, it is equal to 101, but it is in the decimal is equal to 5. So why we are learning all this? A question may come. I'm sure if it is a class, some of you will ask me, sir, why we are using this? What is the requirement of it? The reason is the mathematics of the routers, the digital routers, they cannot understand the simply decimal. They understand the binary numbers. So anything and everything we have to put to them, it has to be converted into machine language, into machine algorithm, where it has to be converted into binary. We have to convert it into binary. Any numbers, it has to be converted into binary. What is called binary math. Now, again, they do two things. One is conversions from binary to decimal, again, decimal to binary. One way to convert from decimal to binary is shown in table. Now, to convert 125 to binary, now we have shown how the binary number 101 converts into 5. That is, binary converts into decimal. Now, I will show you how 125 I will show you how 125 binary is converted into decimal. How 125 decimal converts into binary. 125 is less than 128. So you can place 0 in the column under the 128. The test number remains 125. 125 is greater than 64. So you place 1 in the column under 64 and subtract 64 from 125, leaving your next numbers as 61. 61 is greater than 32, so place 1 in the column under the 32 and subtract 32 from 61, leaving 29. So the way we are basically representing, see 128, 2 to the power 7 means 2 to the power 7 means 2 into 2 into 2 into 2 into 2 into 2 into 2. 7 times you have to multiply. 2 2s are 4, 4 2s 8, 8 to 16, 16 to 32, 32 to 64, 64 into 2, 128. So you can represent, instead of 125, you are taking it 2 to the power 7, 128, because you have to, has to be 2. Then 64, 2 to the power 6, 2 to the power 7 is equal to 0, 2 to the power 6 is equal to 1, 2 to the power 5 is equal to 1, 2 to the power 4 is equal to 1. So ultimately, it's represent 0, 1, 1, 1, 1, 1, 1, 0, 1. To convert 125 to binary, following directions, 13 is greater than 8. So you place 1 in the column and 8, and subtract 8 from 13, leaving 5. So basically what we are doing is we are trying to convert between decimal to binary. Again, we are converting from binary maths to decimal maths. We are again converting 128 to the 7 to the 6 to the 5, 1110001, 10001. Now, IP address classes. What are the IP address classes? How the IP addresses are classed. IP addresses are categorized in classes A and E. Only IP addresses in the ABC classes are available for host assignment. Now, IP addresses are in the ABC classes are available for host assignments. Means IP are classed into different parts. Like the host will have AB classes. Class A address informations, the value of the first octet in between 1 to 127. IP registry assigns the first octet, leaving the last 3 octets to be assigned to host. This allows 24 bits of address space host per network address. So basically, the IP addresses are divided into classes A, B, C, and A address, the value of the first octet is between 1 to 127, and IP registry assigns the first octet, leaving last 3 octets to be assigned to host. This allows 24 bits of address space host per network address. Class B address informations, the value of the first octet is in between 128 to 191, and IP registry assigns the first 2 octets, leaving the third and fourth octets to be assigned to host. Having 2 octets in the pass host ID allows 65534 host per network address. So basically, this IP addresses are classed into 2 or 3 different parts like A address, B address, and C address. A address starts from 1 to 127, B starts from 128 to 191, and C address starts from 192 to 223, and D address starts from 224 to 239, and E address starts from 240 to 255. See this table. The value of the first octet, default subnet, number of networks ID bits is 8, 16, and 24. Maximum number of hosts networks, number of host bits. So these are the different classes of IP addresses. Due to the popularity of TCP/IP on the internet, the unique IP address are almost exhausted. A series of addresses have been reserved for private networks. Try to understand the address is given to what? Address is given to a particular locations. Like in case of your house, address is given to your house. But if there is no space, how can you give an address? So you cannot build any new house. Same thing here. The popularity of TCP/IP has been in the internet was unique, and the IP addresses are almost finished, exhausted. A series of addresses have been reserved for private networks whose hosts can be accessed directly through the internet. So there are certain private networks where this IP addresses are reserved to fulfill the needs. Reserved addresses, class A addresses beginning with 10, class B addresses beginning with 172, and class C addresses begins with 192. That is all private networks. PVN, or sometimes it's called PVN, private networks. The addresses in those ranges can be routed across the internet. If access to the internet is necessary, a process called network address translations is used. The address in these ranges can be routed across the internet. So the private network also can be routed through this network, through this internet network system. And that is through the host, network host. So where, to summarize the whole thing, usually we use TCP/IP and the internet using unique IP address. But since the IP addresses are almost getting exhausted, so we use some time the private networks which has been reserved addresses. And that reserves addresses in case of class A, it starts with 10. The class B starts with the 172. Class C starts with 192. These addresses in those ranges can be routed through the internet also. If access up to the internet is necessary, that is a process called network address translations. Means since it's a special type, you need to address, you need to recognize by the host. Since you have to recognize by the host, we use a process called network address translations, and by which it recognizes these private networks and give them allowance to the network. Now we will start talking onto what is network address translations, what is private networks, all those things we'll be discussing in these chapters. Hi, Bryant, how are you? Bryant.
Hi, Professor. How's it going?
Good. How are you? Good. Good to see you.
Now a lot of students here, Professor. I noticed.
No, I know some of them are here. That's okay because I told them whoever can attend, they will do it because this is a recording class. Next class, 20. Your 20. What is it? Next Saturday, you can see some the guys who has not attended the class. They can see this recording.
Professor, I had a question.
Yeah.
Since we're having this class today on Saturday, this Saturday, we're not having class, right?
No.
Oh, okay.
This is only for today, only for this class. Instead of Friday, instead of Saturday, we are having a recording class here and it will be in asynchronous mode. You can use it on Saturday.
Okay. I have one other question.
Yeah.
I noticed on the assignments on the dashboard, it says that we have two assignments on October 28th, both assignments due on October 28th by 11:59.
No. The guys who has not submitted the notes, not the assignment, it's basically the notes. The guys who has not submitted the notes, you see the announcement, there are certain students who has not submitted the notes. I have given them extended dates up to 28.
Oh, okay. So if you extended the notes already, you don't need to do it, right?
No. The students, please see the announcement, then you will understand. It is the correlations with the, I have made it correlated with the announcement. The announcement says that there are certain, I have observed that certain students has not been not submitted their notes. So whoever has not submitted the notes, I have extended the dates up to 28 because I don't want to just punish them rather than giving an extended date. I have given them extended date for all submissions of all notes, whatever we have taught till now up to chapter 6. Submissions of those notes, dates is 26th.
Okay, Professor. Thank you.
So let me continue with this. So private IP address, we have link local address. It is only not assigned manually or through DHCP. It is assigned automatically when a computer is configured to receive an IP address through DHCP, but no DHCP service available. So usually what happens is we have type of private IP address in a local link address. With usually the private network address, it is a subnet when we have a subnet, then we use private networks with a specific IP address, which I mentioned. It is only assigned manually through a DHCP, and it automatically takes the IP address of the host and then configure themselves. Automatic private IP addressing is another term of the type of addressing. It is called APIPA. It is the private network automatically they find out the address in associations with the host address. IP address, the AIP address are assigned in the range of 169 through 169.254 to this with a subnet mask of 255. So this is the subnet mask. The bottom one is the subnet mask. The original one is the host mask. Classless interdomain routing, CIDR, is a type of address configurations where subnet mask could be configured regardless of the address class. Whatever the address class you have, but the subnet class can be, you can basically configure them. The use of IP address with the default subnet mask is referred to as a classful addressing. The use of IP addresses with the default subnet mask is referred to as a classful addressing. The CIDR, you could assign the IP address of 172 with a subnet mask of 255. In case of 172 would be the network ID and 10 would be the host ID. So basically this class length interdomain routing, when you do the interdomain routing means you are going from one domain to other domain with a specific IP address, how it will configure. The type of address configurations where subnet mask could be configured regardless of the address class. Whatever the address class is, whether it's the A, B, C, D, E, F, whatever the address class is, the interdomain routing can be classless. It doesn't require any class. The use of IP addresses with the default subnet mask is referred to as a classful addressing. So that particular subnet mask, default subnet mask, basically find out the routing domain. CIDR notation uses the format, and the N is the number of 1 bits and the subnet mask. For example, subnet mask is expressed in CIDR notation. The network ID is 24 bits, leaving 8 bits for the host ID. The network ID is 24 bits, leaving 8 bits for the host ID. Usually, in any network ID is 24 bits and host ID is at least 8 bits. We have already talked about the broadcast protocols in our earlier protocol chapters. So when we handshake between the routers to routers, domain to domain, sometime we do broadcast the message from one particular network to the other networks. A broadcast domain defines which devices must receive a packet that is broadcast by any other device. So the broadcast domain has a specific purpose which usually determines that which packet he has to receive and which packet he has to take it and to the other device. A broadcast is a packet addressed to all computers on the network. A broadcast is a universal packet address by which it can take it to the entire network of the computers. TCP/IP communication relies heavily on broadcast packets. DCHP and ARP uses broadcast to perform their task. Every time a computer receives a broadcast package, the NIC generates an interrupt causing the CPU to stop what it's doing and read the packet. Every time when a computer receives a broadcast, so the broadcast packet is an universal by nature, it can reach to any part of the IP addresses. Every time a computer receives a broadcast packet, the NIC generates an interrupt causing the CPU to stop what it's doing and read the packet. So basically, whenever the broadcast happens, the network interface card generates an interrupt. Means its purpose is the NIC basically checks and filters whatever the broadcast happens over this whole entire network, whatever the packets it comes across these domains. It's the computer has its own network NIC cards. That NIC cards immediately stops the ready entry of this broadcasting and check it. Basically, they filters it. The NIC filters it and then gives the admissions. The broadcast is not relevant to the computer. The packet is discarded. Sometimes if there is a spam or something, then this broadcast message is discarded by the computers, individual computer by the NIC. Subnetting. Subnetting is a process that reallocates bits from IP addresses host portions to the network portions, creating multiple smaller address spaces. This is very interesting. What is subnetting? Subnetting is a process that reallocates bits of for an IP address. So you have an IP address, which is mostly a portion of which the host portion to the network portions. Okay, so that creating a multiple smaller address spaces. So you have the main host address, you have the main network address, domain address, and then the subnetting address means that router is associated with other routers, and that router is associated with some switches. Those addresses, that subnetting address is spaces are there, and that is given as a subnetting. In the process, this is basically allows you to reallocates bits from an IP address. You have an IP address. With that IP address, you are opening, you are basically subnetting it. Suppose you have a network which is all set, is working. Now you have a new department. How will you do that? You cannot destroy your existing system. So you have to have a subnetting system by which you can connect with the existing IP address, host IP address, and then make a subnet address and connect with them. Reasons to subnet. To divide a very large network into many smaller subnetworks. As I said, you have a very large networks, and now you have to have a functional networks. Means you want to have something related to financial department, something related to sales department. You want to specify them. You want to have a specific address so that it has a special security on it. You want to signify the individual department or individual task. Based on that, you can have a sub-networking on that particular networks. To conserve ITP addresses, to divide a network into logical groups. You have an IP address, you can convert it into a logical groups based on the use of it. Okay. Guys, slowly and gradually, we are moving towards the actual operational aspects of the IP addresses, how it performs within a network, outside the networks, within a domain, outside the domain, how it works, making a subnetting mask. As I said, you have a host and you can have host to connect with other domains by means of subnetting. Subnetting examples to divide a large network into smaller subnets follow this process. Decide how many subnets you need. Each router interface connections indicates a required subnet. So subnetting is basically to divide a large number of network into smaller subnets. Now, as I said, in an organization, usually we have a large amount of network. And that network usually has several clients, several servers, routers, switches, and whatnot, applicational softwares. And now, based on the need, based on your performance, what you can do is this: you can divide this network into different segments. And that segments means a particular network domain. And that network domain is basically a subnets. Each router interface connections indicates a required subnet. Decide how many bits you need to beat or exceed the number of required subnets. Use the formula 2 to the power n, with n representing the number of bits you must reallocate from the host ID to the internet network ID. The number of subnets you create is always power of 2. So when you create a subnet, is always the power of formula is equal to 2 to the power n. N represents the number of bits you must reallocate from the host ID to the network ID. So is the power of 2 you have to allocate for each subnetting. You have to allocate from host ID to the network ID. You have to allocate them. The number of subnets you create is always the power of 2. So if you need 60 subnets, you must reallocate 6 bits. 2 to the power 6 equal to 64. Reallocating 5 bits gives you only 32 subnets. Reallocate bits from the host ID starting from the most significant host, that is from the left side of the host ID. You must also ensure that you have enough host bits available to assign to computers on each subnet. To determine the number of host addresses available, use the formula 2 to the power n minus 2, with n representing the number of hosts, 0 bits in the subnet mask. So basically, you must ensure that enough host bits available to assign the computers. So we have to first examine that whether we have enough amount of bits available to assign to the computers within that host subnet, within that host, which that host is basically going to allocate to these subnets. The way the formula is 2 to the power n minus 2, where n representing the number of host bits in the subnet mask. A pattern emerges shows that the first 16 of the possible 64 subnets are the last subnets created for network. Basically a pattern, it emerges a pattern. When you make a subnet, it generates some kind of pattern by which it shows that the first 16 is the possible 64 subnets which are created. The pattern to the subnet network numbers is increments of 4. To derive this pattern, look at the octet where the subnet bits are reallocated. Look at the rightmost reallocated bit. The subnet increment is determined by the binary place value of the bit. So octet, where the subnet bits are reallocated, a rightmost reallocated bit. So you have to, if you want to derive this pattern, if you want to see the pattern which emerges, you have to see in this way. Determining host addresses. Host address in each subnet can be determined by cycling through the host bits. The subnet of 172. So the host is 172.0.20. This one would have a host address of through 172 to this one. So the host address is in the left side and the cycling address is in the right side. So the mask address in the right side. The subnet mask examples, calculating a subnet mask. See, A, B, C, these are the three different classes. Network numbers. Network number is 192.168.100. Calculating a subnet mask based on needed host address to find out what prefix to assign an IP network based on the number of host addresses required for the network. Determine how many host bits are needed to support the number of hosts specified. Subtract this number from the number of network bits. So, for example, IT address, network address is 172.16.16 that that will support 60 hosts. You need six bits to the host because 2 to the power 6 is equal to 64, which is the closest power to 2 a power of 2 to 60. The prefix is 32 minus 6 is equal to 26. CIDR notations would be 172, 16, 16, 0 to 26. So this is the CIDR notations. Network ID required host, host bits required, network ID bits, CIDR notations. So netting, subnetting, what we discussed till now is basically it comes derived from the host. The host has its own IP address, and that IP address stays in the left side of it, numbers, and it is associated with the subnetting whenever we require to the large networks to be dissociated and the functions to be segmented or attached a network. We make a subnetting of the host, and then subnetting gives us a subnet IP address, which is basically works with the host address, and then it has 8 bits characters, 16 bits, 32 bits, and 64 bits. So these are the ways we are having a host net and then having a subnet of it. Now, what is supernetting? Supernetting is sometimes necessary to solve certain network configurations problems and to make routing tables more streamlined. Like if you see the cable lines, sometimes the cable lines they keep on connecting between one pole to the others. It becomes very confusing. So supernetting is such that when you have a network configurations and it is very complex by nature, it's it is having a different functions, then supernetting is sometimes necessary to solve certain network configuration problems to make routing tables much more streamlined and much more professional. Subnetting can be referred to as a route aggregations or route summarizations. Means what it does is it takes care of the whole networking family, and then it's basically streamline them, connect them properly, streamline them so that it works in a proper way. It is connected in a proper way and there is the least amount of interruptions with the IP address of the both net and the subnet. The supernet is required to basically to solve certain network configurations problems and to make a routing table more simpler and streamlined. So it basically does the route aggregations or summarizations to a single entry. This can drastically decrease the table size on internet routers and increase router speed and efficiency. So what is supernating? Router sends a summary of its routing table to router B, and then from network one network to the other networks, it is basically supernated. Router A sends summary of its routing table to router B, and then it goes from one particular network to the other particular networks. See how it is done. This is the entire routers. This is one, and this is router B. So this router A sends summary to its routing table to router B. So this is superknitting. Basically, it summarizes whatever is happening. It is going from A to B, so that if there is any problem, the router B can take care of it and satisfy the demands. So rules for IP address assignment: a host can be assigned only class A, B, and C class address. Every IP address configuration must have a subnet mask. So how do you make IPv4 addresses configurations? So what is the rule of it? The rule is basically very simple, that you need to have a host can be assigned only on class A, class B, and class C address, and each one should have an IP address. Every IP address configuration must have a subnet address. It should have a subnet mask. All hosts on the same physical network must share the same network ID in their IP address. So in the family of the same physical network, you have to share the same network ID in the IP address. All host IDs on the same network must be unique. If it is say 172, it should be 172 across the whole network. You cannot change it. Otherwise, it will be disconnected. It will not be able to recognize between the host and the subnets. So the entire family of the network should have the same address, IP address of the host address. You can assign an IP address in which all the host ID bits are binary 0. You can assign an IP address in which all the host ID bits binary is 1. So the host ID should be binary should be 0 to 1. Computer assigned different network IDs can communicate only if the router is present to forward packets. So if you want to have a private networks, it has to have you can forward the packets to the private networks, provided they maintain the network IDs. The default gateway address assigned to a computer must have the same network ID as the computer. So if you have a default gateway, that gateway should have the same network ID as that of computer, so that it can recognize. Configuring multiple IP addresses. Windows operating systems allows assigning multiple IP addresses to a single network connections via advanced TCP/IP settings dialog box. How do you configure multiple IP addresses? Now, you have IP address, you have to configure them, you have to streamline them, you have to bring in under same umbrella, so that with the same IP address, they can work within the same family of the IP family or same domain. Windows operating systems allows assigning multiple IP addresses to a single network connections via advanced TCP/IP settings dialog box. So in the operating system, because as you know, this has to work in the operating systems. Though it's an internet protocol, but it has to go to the computers. And that computer is governed by the different kind of operating systems of the computer. Windows, Unix, Linux, all those window operating systems should recognize all these hosts. Otherwise, it cannot reach to the ultimate computers. Multiple IP addresses can be useful in these situations. The computer is hosting a service that must be accessed by using different addresses. The computer is connected to a physical network that hosts multiple IP addresses. Configuring multiple IP addresses, you have to have an IP settings, then IP address, subnet mask, category, gateway, and then you have a multiple IP address, but that addresses has to be subnet with the main host addresses, and the advanced TCP IP settings should be in the same dialog box so that you can configure them from a single point of connections. A default gateway is almost always used in IP configurations. When you want to use an IP configurations, the default gateway is used. The default gateway's address must have the same IP network ID as the host network ID. So the default gateway is almost always used in IP configurations. The default gateway is almost used in IP configurations. When you use a gateway, this is always used in IP configurations. The default gateway address must have the same network ID as the host network ID. Slide shows how the distinctions computer network address is determined using the subnet mask. See how the default gateway means each and every networking IP address has to go through the default gateway system. What does it do? It's basically find out which is relevant and which is not relevant, because when it is broadcasted, it goes to the entire network. And now the job of this default gateway is to filter the right informations in each and every point of contact of the IP address. And also, it does determine the destination computer network's address with the subnet mask. So it also verifies whether it is really reaching to the right network address or to the subnet mask which has been assigned for. So the destination is the right destination where he is reaching. That is his ultimate objective, to find it out. So now we have to enter into more complex things. But before that, from 38 slides, let me take 5 minutes break, and I will rejoin with you 5 to 10 after 5 to 10 minutes. Because this is a little critical subject, so it requires a little break. I will come back to you after. Now it's 10:03. I'll rejoin at 10:15. So guys, we are back now. So what we were discussing, that configuring the default gateway, the gateway for each and every networks, we have a gateway system which basically determines the network destinations with the proper, and also filters the network address and helps the network address to connect with the subnet mask and put it in the proper computer network address. Now, in order to do that, we basically use a kind of a subnetting mask and IP addresses to determine them. Configuring the default gateway. Using multiple default gateways, just as you can configure multiple addresses, multiple gateways can be configured. Windows attempts to select the gateway with the best metric automatically. Metric is a value assigned to the gateway based on the speed of the interface used to access the gateway. Using multi-homed house servers, the multi-home servers has two or more NICs, each attached to a different IP address. Each NIC requires its own IP address for the network to which it's connected. Reasons for this type of configurations: a server is accessed by internet clients and external clients. A server provides resources for computers on multiple subnets of the network. A server is configured as a router or VPN server. Multi-home servers can run into routing issues due to multiple default gateways being configured. So when we have a multiple default gateway, it basically takes you from configurations. Multiple gateways can be configured. Windows attempts to select the gateway with the best metric automatically. Metric is value assigned to the gateway based on the speed of the interface users to access the gateway. Metric is basically assigns the gateway speed, what speed it is given. A multi-home server has two or more NICs, each attached to the different IP address. Each NIC requires its own IP address for the network to which it is connected. Reasons for this type of configurations: the server is accessed by internal clients and external clients. A server provides resources for computers on multiple subnets of the network. A server is configured as a router. A server is configured as a router or VPN server. Multi-home servers can run into routing issues due to multiple default gateways being configured. Using the route command, Windows computers maintain a routing table that indicates where the packet should be sent. Based on the packet's destination address, typing route print displays the routing table. Results are displayed in the 5 columns: network destinations, network masking, gateway, interface, and metric. So the configurations of the default gateway, the route command, Windows computer maintain a routing table that indicates where the packet should be sent. As I said, by default, it says that where the packet should be sent with the packet address, with the proper packet address and the packet destination's address. Typing route prints displays the routing table. So what it does, it says So the routing command basically gives you the routing table that indicates where the packet should be sent based on the packet destinations, where is the address, which address it should be sent, and it also prints and displays the routing tables into 5 columns. So what is the network destinations? What is the network's masking, net masking? What is the gateway? What is the interface? And what is the metric? At what speed it is going? So the 5 things are given in the network routing command. What are them? One is network destinations with the proper IP address, including the network masking, net masking, what is called net masking, which subnet it is going, what is the gateway, by default gateway, what is the interface it has, and what kind of metric it follows. The route command can be used to change the routing table and to fix issues caused by using multi-home server. So when you use multi-home server, the problems when it happens, then this route command basically helps you to find out from the routing table what kind of problem you are facing so that the problems can be rectified. This is the results of the route print command. Configuring the default gateway, multi-home server. This is the multi-home server, and default gateway. This is the routers, this is server. Other command line tools available to assist with IP configurations. Netis, ipconfig, ping, ARP, tracker. So these are the network commands which usually use for the IP configurations. When we configure the IP configurations, usually the programmers use these commands nnets sh, ipconfig, ping, ARP, trackers, NS lookup. Additional tools are available but generally used to verify correct IP configuration settings and connectivity. So these are the commands which we use for IP configurations. So I'm basically trying to find out some key informations which has been given in the chats. I'm basically taking care of the chats also. A lot of students has given me the chats. So IP configuration command line tools using netsh command can be used for many tasks such as firewall and IP address configurations. So we are, as I said, that when you use certain commands to configure the IP address, we use certain commands. That is not being used by the common people. That is usually used by the configurations are done by the network people. Suppose if some of you become a network engineer, then you have to do this. You have to use certain commands to configure this configurations of the IP address. So you use netsh, ipconfig, ping, arp, tracert, nslookup. Now, one by one, what is the use of netsh? The netsh command can be used for many tasks such as firewall and IP address configurations. To see a list of NH command type NSH, to configure the IP address of an interface named Ethernet 0, use this command, such as next interface IV4 set address. So you can get this address. To set a primary DNS server, use this command netsh and Ethernet. So basically, if you want to find out a proper Ethernet networks, what is happening in the IPv4 set address, then you have to type NSH backslash forward slash, then with questions. Then ipconfig, what is it? Is usually used to display to computer IP address settings, but it can perform other tasks also. All, release, renew, displays, flash DNS and registered DNS. So ipconfig is basically gives you to display the computer IP address, and also it helps you to give you the options like all, release, renew, displays. All these commands can be controlled by this ipconfig. Very interesting. Using ping. Ping is basically used to test the connectivity between the two computers. If you transfer funds from one bank to the other, usually they say that we have sent the ping. Ping means there is like a pilot van when the diplomats goes from one place to other. Usually the pilot van goes first to make clear of the roads. Same thing here. The ping is basically makes the connectivity between the two computers. Ping makes a test connectivity between the two computers. It makes you alert that yes, the information is coming. So the ping is used to test the connectivity between the two computers by sending ICMP echo request packet. So it sends the packet, and by sending that, it's basically see that whether the two connectivity are connected, and they are by default they are into system. If the destination receives the ICMP code request and can respond, it will reply with an ICMP reply packet. So immediately as soon as it gets there, it sends the packet reply from bytes. To see the options available for the ping command. So the ping is basically to see that whether the two computers are connected or not. Using ARP command displays or makes changes the address resolutions protocol. If you want to change, can reconfigure the address resolutions, then you can basically use address resolution protocol, which contains IP address, max address pairs, can add static ARP entries. Some options of ARP command displays current ARP entries, delete ARP entries, adds a static ARP entry. Using trackered, this command is usually called trace route because it displays the route packets This command is usually called trace route because it displays the route packets text between the two computers Trackers used works by sending out packets with a TTL value starting at 1 and increases the value until the destination is reached. This command is useful for troubleshooting the routing topology of a complex network and finding bottlenecks. It displays the time it looks to receive a reply from each router, which could indicate which bottlenecks might be. Using NS lookup, this command is used to test and troubleshoot DNS operations. NS lookups can be used in command mode or interactive mode. In command mode, you type NS lookup host to query for the host address. And in interactive mode, you can simply type host to get the host address. Typing a question mark at an interactive mode prompt gives a list of available options. Network address translation allows an organization to use private IP addresses while connected to the internet. Network address translations allows an organization to use private IP address. If you want to use the private IP address, then you have to go to NAT and configure them. NAT process translates the workstation's private address as a packet leaves the corporate network into a valid public network address. So NAT takes care when the packet leaves the official network and moves to the private network, then NAT takes care of the translations of that network address. When data returns to the workstation, the address is translated back to the original private network address. So when between an official network address or original network address and the private network address, what it happens is whenever it goes out, goes through the network address translations, and again when it comes back from the private to the official network, then again it is basically checked and through the network address translation. NAT is usually handled by network device connected to the internet, such as router address, such as router. Router basically does this NAT services. Address translation is kept track in the network NAT table. See this private network address, public address. So this is connected to the network and it is connected. Port address translations allow several hundred workstations to access to the internet with a single public internet network address. Each packet contains source and destination IP addresses. So port address translation allows several hundred workstations to access the internet. You try to realize the situations where you have several thousands and thousands and thousands of computers and workstations. How you are connected to that family allows several hundreds of workstations to access the internet with a single public internet address. We have a single public address, as I said from the very beginning. Each customer has a single public internet address. Each packet contains source and destination IP addresses. Along the source and the destination port numbers. It has a port number, what is called port address translations. A single IP address is used for all workstations, but different source port numbers are used for each communication sessions. The port number basically gives you that when is the traffic going, at what segment. It is divided into segments. So it also gives you the time, at what time it goes from one place to the others. Network address translations. Internet Protocol version 6. Now, we have spoken till now, it is basically Internet. Today, we are in 2020, mostly from 1980, we are getting the facilities of Internet. When the Internet came into existence, at that time, the Internet version was IPv4. Now it has moved to IPv6. So until now, whatever we described, it was based on IPv4. Now we are moving towards IPv6. IPv4 was developed more than 40 years ago and is showing its age as its address space becomes used up. So what happened is it has a address. That address is now eat up. The whole space is done. Now it has to be revamped and reconfigured, replacement with the new versions. That IPv6 is a replacement for IPv4. IPv4 addresses looks very different from IPv4 address. So IPv6 address are quite different than IPv4 address. They have a built-in hierarchy and fields with a distinct purpose. Methods have been developed to allow IPv4 and IPv6 networks to coexist and communicate to each other. When they developed this IPv6, two things has been taken care of. What are they? First thing is that whatever has been developed in IPv4, they cannot discard it. They can discard the address. They have changed the address numbers and they have replaced it and built in hierarchy with the field of distinct purpose. But over and above, what they did is they have found out some coexisting logics so that both IPv4, the past routers, and the present IPv6 routers can communicate each other and can coexist each other, can handshake each other. The objective is not to discard the whole system, but the objective is to revamp the system to make them more technology savvy and upgrade them, reconfigure them, and so that they can coexist with the new one, IPv6. At the same time, they can perform much, much better with more high metrics. That is the purpose. See, what is the let us give you an overview of IPv6. What is the overview? Originally named IPNG Next Generations, it was originally known as IP Next Generations. IPv6 was created in 1994 by the Internet Engineering Task Force. Internet Engineering Task Force has developed this in 1994 and it was originally known as IP Next Generations. IPv6 includes the following improvements. What are the improvements? You have to understand that why it is required and what is the added value the IPv6 offers in comparison to IPv4. It has a larger address space, hierarchical address space, auto configurations, built-in quality of server support, built-in support for security, support for mobility, extensibility. See, these are very prime aspects of the whole IPv6. So if I ask you, what is the difference characters or how you differentiate between IPv6 and IPv4, this will be your answer. IPv6 includes the following improvements and differentiate with IPv4 with the following characters. Number one, with the following benefits. Number one, larger address space. Second, hierarchical address space. Auto configurations. Built-in quality of server support. Built-in support for security. Support for mobility, extensibility. So larger address space, hierarchical address space, auto configurations, it does the auto configurations, built-in quality of server support, built-in support for security, support for mobility, extensibility. It has done extensivity support also. IPv6 subnetting has done IPv4 v4 is no longer applicable. IPv6 uses 128 bits instead of IPv4 32 bits for an address. IPv6 addresses are written in as 8 16-bit hexadecimal numbers separated by colons. Things to note about IPv6 addresses: one or more consecutive zero values can be written as a double colon, but only one double colon can exist in IPv6 address. Leading zeros or optionals, hexadecimal numbers are easier to convert to binary. The interface ID is an IPv6 is typically 64 bits. It uses the interface 48 max address for a larger portions of the address as well as 16-bit value that is inserted from the 24 bits of the max address. IPv6 interface ID can be assigned to a host in these ways using the 48 max address. First two zeros in the max address are replaced by 02. This auto-configured 64-bit ID referred to as an extended unique identifier interface ID. Remotely and randomly generated permanent interface identifier, temporary interface identifier. So basically, the its structure is like this. It has an interface ID. Interface ID can be assigned to a host in this way using 48 max address, randomly generated permanent interface identifier, a temporary interface identifier, and via DHCPVX and manually. In case there's nothing is happening, so you can do the manual process also. IPv6 defines the following address types: unicast, multicast, anycast. Unicast and multicast addresses in IPv6 performs much like their IPv4 counterparts with a few exceptions. So it has a unicast, multicast, and anycast. To different addresses, it has unicast, multicast, and anycast. What does it mean? Unicast means it goes from one to one. It can go from one to multiple. That means it can broadcast. Anycast means it can go from official to the private, private to the official. So any kind of networks it can go. Unicast and multicast addresses is IPv4 perform much like the IPv4 counterparts with few exceptions. Three primary types of unicast addresses: link local addresses are unique local address and global unicast addresses. Unicast addresses specifies the single interface on a device. Three primary types of unicast addresses are there. Link local addresses starting with FE18 or self-configuration used to computer communications. Unique local addresses starting with FC and FD that are used for firewall and pre-configured on routers. Global unicast addresses accessible on the public internet and can be routed. IPv6 special purpose addresses. Local loop address is equivalent to 1. Zero address is used as a place order in the source address field, an outgoing IPv6 packet, and is returned as. Documentations. The global unicast address has been reserved for use in books and other documentations. So basically, the special purpose address, it has for loopback address, documentation purpose, and transition process. So basically, I will let me reply back. Basically, we were talking on IB6 unicast addresses, special purpose addresses, loopback address is equivalent to 127, zero address, documentations, and transitions. There are 4 different purposes of the IBP special address. Is the loopback address is equivalent to, is more or less used in IB4 also. Zero address is used as a placeholder in the source address field as an outgoing IPv6 packet and is written as this with the 4 semicolons. Documentations. The global unicast address has been reserved for use in books and other documentations addresses. So for only for documentation purpose, the books addresses, we can use this particular address. IV4 to IV6 transitions. You need a transition, isn't it? We have a lot of IV4 routers. So how will you do that? That IV4 to IV6 transitions, several address prefixes are used for transitions of IV4 to IV6. Subnetting with IV6. Subnetting will still exist in IV6, but due to the large address space available, most addresses allocations will have 48 prefix. This means of the network ID is 48 bits, and the network administrator has 80 bits for assigning subnets and the host IDs. So the network administrator has 80 bits, out of which the network ID is 48 bits. 80 bits allows 16-bit subnets, allowing up to 65.56 subnets. Unicast addresses, global routing prefix, subnet address, interface address. Multicast address, now we are into multicast address. In IB6 performs the same functions as its counterparts in IB4. Multicast address begins with FF and have the following structure: flags, scope, and group ID. 4-bit field, scope, and a group ID. And any cast addresses can be assigned to multiple address interfaces on different nodes, are recognized as any cast addresses only by the device that use them, are assigned on routers and are used to allow other IB6 nodes to deliver packets to the routers. IB6 auto configurations occurs by the 2 methods: stateless auto configurations and stateful auto configurations. The node listens for routers and advertisement messages from a local router. Stateful auto configurations, the node uses an auto configuration protocol such as DH to obtain the IB6 addresses and other configurations information. The Windows auto configuration steps and initializations, the link local address is determined. The link local address is verified as unique by using duplicate address detentions. The address is verified as unique. The address is assigned to the interface. The host transmits a router solicitations message. If no router advertisement messages are received in response to the solicitation message, the host attempts to DHCP to an address. The Windows auto configuration steps. How do you make the auto configurations to a window? Or how does this IV6, IV6, IPv6 makes the auto configurations in the Windows? There are six steps. At initialization, a local address is determined. What is the local address? It determines the local address. The linked local address is verified by unique by using duplicate address detections. So whether it's a unique number that is detected or is a duplicate number, if the address is verified as unique, the address is assigned to the interface. If it is the address is recognized as a unique address, then it immediately goes to the interface. The host transmits a router solicitation message. The network host, they basically transmits a router solicitations message. Means, well, you can send it to this interface. If no router advertisement messages are received in response to the solicitation message, the host attempts to get an address. The host sends a solicitations message. If in reply to that, if the no message is given, then to the host, then a new address is floated by DHCPV6 servers. If router advertisement message is received, the prefix in the router advertisement is used along with the interface ID to configure IPv6 address. Technologies to help ease the transitions to IPv6. Dual IP architecture. You have to have a dual IP architecture because you have to recognize both IPv6 and IPv4. IPv6 over IPv4 tunneling. You have to tunnel out. Tunneling, why is tunneling? Because you have IPv6 infrastructure and if you have IPv4, you have to connect between these two. So you have to have a proper tunnel. Intra-site automatic tunnel addressing protocol 624 TILDO. Dual IP layered architecture means the computer can communicate directly both IPv6 and using native packet types. Computer running either architecture can encapsulate it, IPv6 packets and IPv4 header, a process called tunneling. So both of them can be connected by means of tunneling process. Tunneling is a network protocol technique that allows transmitting a packet in a format that otherwise is incompatible with the network architecture by encapsulating the packet in a compatible to connect between these two different IPs of different strengths, of different architecture, and allows transmitting the packet from one format to the other. An IPv6 device. So we had certain problems today in terms of internet, and a lot of messages are coming from the students, so I have to reply to them. Well, we are now trying to move towards IPv6 over IPv4 tunneling, a router to router IPv6 over to IPv4 tunneling, how it is happening, server running and IPv4 applications. And this is the router which is basically interfacing between IPv6 and IPv4 routers. It has an interface capability. It has a protocol which understands between, it takes care of the tunneling aspects. And then it moves to the IPv4 network. And then again, there's a router which handshakes them. Then it brings to the IPv6 host. So try to understand the situations. In the two ends, we have IPv6 host. Okay, one server running in the IPv6 applications, and another one is the host. This is the host IPv6, and this is a server running in applications, which is also IPv6. But in between, we have certain servers or in some IPv4 routers, which is basically having an interface between the IPv6. So IPv6, we have application here, and this is the router. This is the host IPv6. And then we have existing networks, the old network, and then again we have, so between the two ends, we have two routers, which is basically making the interface between IPv4 to IPv5, IPv6 to IPv4, and IPv4 to IPv6. And then it's going back to the host as a IPv6. So intra-site automatic tunnel addressing protocol. Intra-site automatic tunnels addressing protocol is used to transmit IPv6 packets between the dual IP layer host across the IPv8 network. So we have two layers. Initially, we said that IPv6 has the capability of having two layers of IP. That is the major the distinction between IPv6. IPv6 has two IP layers host across the IPv network. This protocol enabled by default, so it does not require any manual configurations. So it is by default, it can configure the first 64 bits an address and a link address. So this is the whole thing. It happens between while tunneling between IPv6 and IPv4. It happens in intra-site automatic tunnel addressing protocol. 6 to 4 tunneling provides automatic tunneling IPv4 traffic over the IPv4 network. It can provide host to router and router to host tunneling, but is often used to create a router to router tunnel. Basically, as I said to you, this is the host and this is the application server. Server between them, this is the IPv6 to IPv4. We have one router which is basically interfacing between the IPv6. Again, we have an IPv4 network, and then again we have a router which is basically interfacing between IPv6 and IPv4, and again we have an IPv6 host. So this is the whole tunneling from 6 to 4. This tunneling is done. The key of 6 to 4 tunneling is 2002 prefix. The router is configured to perform 6 to 4 tunneling recognized as 64 address. Terudo tunneling. Terudo is an automatic IV over IV tunneling protocol that solves the problem to 6 to 4 requirements. So basically, it's an automatic. Same thing. This is nothing but Terudo is an automatic process by which it converts the tunneling process from IPv6 over IPv4 tunneling protocol. Okay, so this Terudo is, as we said, is something which basically converts the first 16 bits as always Terudo prefix, and the next 32 bits represented by P characters and Terudo servers. The next 16 bits characters, Terudo's flags, the specified processing options, and that P characters represent the obsessed UDP port, and the client uses the Terudo traffic. So now with this, we are ending this chapters. So what we have learned in this chapter, what we have learned in this chapters, we have learned what is IPv4, what is its characteristics, how it works, what is its objective, what kind of issues they have, what is their address, what is the address of IPv4, how it works, and how it handshakes between in different situations, from server to server, from network to subnetting, how the whole address is recognized, host, mask, subnetting, and also the private networks, how it works in the private networks, how by default it gets checked, how it's before it comes to the official networks, how the private networks are being filtered to the official networks. This was one part of discussions of the IPv4, which has started from 1980 in the internet world. Then in 1994, this has been upgraded to IPv6. That IPv6 is more or less equals to IPv4, having more or less same, but that has different configure, that has different characteristics. Those characteristics are destinations. It has, first of all, it has a dual tunneling aspects. It can have 2 IP addresses at a time. It's have a proper destinations method. It gets the it's once the message is reaching to the ultimate destinations, it sends a message back to the host, and it's basically confirms, and then only the protocols moves. So this has several aspects. It has 7 benefits of this. It has an interfacing protocols by which it can tunnel between 2 aspects, like one is your IPv6 and one is IPv4. It can tunnel them, and basically by means of binary mathematics, from decimal to binary and binary to decimal, they can convert it into a proper system, and the communications can happen. So with this, I'm ending chapter 6 today with a note and advice that you must read these chapters very carefully, because this is quite interesting, as well as it is very math based. The student doesn't have a math background, will face little difficulties. If you have any questions, you can ask me in the next class, in the sessions when I'll ask you to ask me. Third is, I will also request all of you to cooperate with my project leaders who has been assigned to develop the project synopsis. Please help him or her, and then he is supposed to submit the project synopsis. So help him, give your part. I will request all my students to actively participate with the team leaders and make it happen. Second is, if someone has not submitted the notes yet, please submit it. I have extended the dates up to 28th of October. You can submit all your previous notes of the previous classes up to 28th of October. I Don't want any of my students to miss to submit the notes. So that's the reason I've extended the dates. And last but the least is, if anybody has not submitted the quiz or the midterm, please do it. I will give you relaxations in terms of time. If you cannot submit, send through email, send through your if you cannot submit through modules, then submit through emails and let me know. Okay, all the best. Take care of yourself. Have a nice weekend. See you next week. God bless you.